Hi, today's video discussion is about the electromagnetic spectrum. After watching the video, we hope to identify the different kinds of electromagnetic waves and their uses. And second, differentiate these waves in terms of their wavelengths and frequencies. So if you're ready to listen and you have your learning activity sheet with you, then we can now begin. We'll start our discussion by recalling what an electromagnetic wave is. An electromagnetic wave is a type of wave that does not require a medium. This means that EM waves do not require a material through which the wave will travel or propagate. In discussing electromagnetic waves, it's important that we start by identifying the scientists that helped discover EM waves. And they are James Clerk Maxwell, Heinrich Hertz, and Guglielmo Marconi. So James Clerk Maxwell was a theoretical physicist, and after playing around with different equations describing electromagnetic phenomena, he was able to discover that EM waves travel at the speed of light. So this means that all EM waves travel at 300 million meters per second. Because of this, he said that light is an electromagnetic wave. Now take note that because he was a theoretical physicist, he was able to prove this using calculations and equations. So it was his colleague, Heinrich Hertz, who conducted an actual experiment to prove Maxwell's claim. And he was able to successfully do it. So through the experiment, he was able to prove that EM waves travel at the speed of light, and light is also an electromagnetic wave. Now, it was Guglielmo Marconi who applied EM waves by sending information in a wireless telegraph. Because there are different kinds of electromagnetic waves, we try to arrange them in terms of their wavelengths and frequencies. That's why we have an electromagnetic spectrum. In this spectrum, we see that there are 7 kinds of EM waves: radio waves, microwaves, infrared waves, visible light waves, ultraviolet rays, X-rays, and gamma rays. Now, looking at this spectrum, we see that each wave has different wavelengths. And using the diagram, we see here that radio waves has the longest wavelength, or the longest lambda. Okay, take note that wavelength is denoted by the Greek letter lambda. And gamma rays have the shortest wavelength. Now notice for gamma rays in the diagram, the distance from one crest to the other crest is very, very short. That's why we say that they have the shortest wavelength. Now in terms of frequency, or the number of waves that you see, now you notice here that gamma rays are more frequent. Maraming beses siya lumalabas. So among the 7 waves, gamma rays have the highest frequency. Kasi marami tayong nakikita sa diagram natin. On the other hand, radio waves, because they have longer wavelengths, we don't see a lot of radio waves. So it does not frequent a lot. That's why we say that radio waves has the lowest frequency. Now we see some kind of relationship that if the wavelength is long, the frequency is low, or if the wavelength is short, then the frequency is high. This means that wavelength and frequency are inversely related. Yung isa mataas, yung isa mababa. Now, we can zero in the visible light spectrum where we see different colors, the Roy-G-Biv, and looking at this diagram, we can also see that each color has different wavelengths. And this diagram tells us that the color with the longest wavelength is actually red, while violet has the shortest wavelength. Now, because violet has the shortest wavelength, it has the highest frequency, while red has the lowest frequency. Because again, wavelength and frequency are inversely related. Now we go back to our uh, previous spectrum, the electromagnetic spectrum, and we see here that there are many uses, and we're very familiar of them because we use them in our everyday lives, especially in cell phones or in heating food, for example, or when we go to the doctor or to the hospital to get an x-ray. Now, aside from wavelength and frequency, we can also see here that gamma rays, because they are used for medicine or for killing cancer cells, they are high energy waves. They emit a lot of energy. Well, radio waves, or the waves that are on the left side of the spectrum, are actually low energy waves. This means that when we expose ourselves to ultraviolet rays, X-rays, or gamma rays, we need to protect ourselves because they emit a lot of energy. Now, to summarize our lesson, take note that all these electromagnetic waves travel at the speed of light, but they differ in terms of their wavelengths and frequencies. Now, those with long wavelengths have low frequency, like radio waves, and gamma rays, which have short wavelengths, will have high frequencies. Moreover, waves that have high frequency are also high energy waves, and waves with low frequency are also low energy waves. So looking at this spectrum, we see that gamma rays emit the most energy. That's why it's the most harmful, where radio waves emit the lowest energy, so they're the least harmful. So I hope that clears out our lesson about electromagnetic waves, and thank you for listening.